So my dear students, this particular video is for sure going to give you some 20 marks in less than 10 minutes. I would want you guys to watch this video till the end. I'm going to discuss some 5 frequently asked concepts, right? 5 concepts means 20 marks for sure. Question based on empirical formula, question based on orbital angular momentum, question based on equivalent mass of the substance that undergoes disproportionation, question based on entropy change, and the question based on how to check the strongest oxidizing and reducing agent, right? So watch this particular video till the end so that you can fetch these 20 marks for sure in less than 10 minutes. My dear students, have a look what exactly I'll be doing. So first of all, the first concept, that is calculation of empirical formula. My dear students, in the question, you will be given with a compound, and that compound will be containing certain elements like X and Y. The mass percentage of X is given, the mass percentage of Y will be given in the question, and you will be supposed to check the empirical formula of the compound. What exactly we are supposed to do in order to get the empirical formula? My dear students, there are 2 steps which you have to do. That's all. First step, to calculate the atomic ratio. Second step, to calculate the least atomic ratio. How do we calculate the atomic ratio? Whatever is the mass percentage of an element, divide that mass percentage of the element by the respective atomic mass. The value comes out to be 1. Similarly, the mass percentage of the element here is 20. Atomic mass of the element is 40. The value comes out to be 0.5. So what do I call these 2 terms as? I got the atomic ratio of X and Y over here. Okay. Now, which one is the least number among the 2? The least number among the 2 is 0.5. Divide both these terms by the least number. So 1 divided by 0.5. Similarly, 0.5 divided by 0.5. This value came out to be 2 and this value came out to be 1. So I would say the least atomic ratio of X and Y. The least atomic ratio of X and Y, it came out to be 2:1. And the least atomic ratio, it gives you the empirical formula of the compound. So you can say directly the empirical formula of the compound here is X2Y1. But remember, in the question, either mass percentage will be given, or masses of elements directly will be given, or the mass ratio of the elements will be given. But you are supposed to follow the same procedure. Whatever is given, mass percentage or mass ratio or given masses, right? Anything of the 3, if it is given, what you are supposed to do? First get the atomic ratio, then get the least atomic ratio. You'll be getting the empirical formula of the compound. This sort of a question is frequently asked in your NEET examination. My dear students, point number 2. A question is asked in which you will be supposed to calculate the orbital angular momentum. And how do we exactly calculate the orbital angular momentum? There is a formula for that. Under root of L into L plus 1 h upon 2 pi, right? This L over here, it represents your azimuthal quantum number. My dear students, first of all, L value is taken to be 0 for your S, L value is taken to be 1 for P, L value is taken to be 2 for D, L value is taken to be 3 for F. Okay. So first of all, here you have got S. For S, the value of L is 0. If the value of L is 0, I would say orbital angular momentum in case of 2S. L is 0, put the value of L as 0. So the orbital angular momentum comes out to be 0 in this particular case, right? Similarly, again you have got S, the value of L is 0. You have got nothing to do with the quantum number. You have got nothing to do with the principal quantum number. You just have to do with L. The value of L again is 0. Put the value of L in the above equation. Orbital angular momentum again comes out to be 0. Now, my dear students, here you have got P. In case of P, the value of L is 1. If the value of L is 1, you will say orbital angular momentum will be equal to under root of L into L plus 1 multiplied by h upon 2 pi. So this will come out to be under root of 1 plus 1, 2, root of 2 h upon 2 pi, or you can say it is going to be h upon under root of 2 pi, right? This is the orbital angular momentum in case of 2p. Now, I would want to know the orbital angular momentum in case of 3D as well in the comment section of this particular video. And I'm pretty much sure you can easily calculate it. This is a short question which is asked almost every year in your NEET examination, my dear students. Moving on to one more concept. My dear students, how do we exactly calculate equivalent mass? Equivalent mass of the substance is calculated as molar mass of the substance divided by n factor of the substance. Now, in this particular case, if I ask you what is the oxidation state of bromine here, it is 0. What is the oxidation state of Br here? -1. What is the oxidation state of Br here? +5. When you calculate it, 0 to -1 means decrease in the oxidation state. 0 to plus 5 means increase in the oxidation state. Whenever oxidation state of same element, increases as well as decreases simultaneously, we say that particular species undergoes disproportionation. How do we calculate n factor of the species which undergoes disproportionation? It is simply going to be n1 n2 divided by n1 plus n2. Remember this particular formula. N factor of the species that undergoes disproportionation is always equal to n1 n2 divided by n1 plus n2. Now the point is, how do we get the value of n1? How do we get the value of n2? See guys, how do we get the value of n1? See, 0 to minus 1. What is the change in oxidation state? Final minus initial. The value comes out to be 1. 1 is the change for one atom of bromine. But over here I've got two atoms. So multiplying it with 2, the value of n1 came out to be 2. Now if I talk about n2 value, 0 to plus 5. Change is 5. 5 is the change for one atom. But over here I've got two atoms. So 5 2s comes out to be 10. So you got n1, you got n2. So its n factor has to be equal to 10 multiplied by 2 divided by 10 plus 2. So it will come out to be 20 divided by 12. So 4 5 4 3. So 5 by 3 is basically the n factor of bromine over here. And my dear students, if you got the n factor of Br2, you can easily calculate the equivalent mass of Br2, which is its molar mass divided by its n factor. So it is going to be simply 3 divided by 5m if the molar mass of Br2 is m. Perfect. I believe this sort of a question, if asked in the examination, you should be in a position to solve this particular question as well, right? My dear students, moving on to one more concept that is based on the sign of delta S, the sign of entropy change. First of all, during the process, if the entropy increases, delta S value is taken to be positive. During the process, if entropy decreases, that means delta S sign has to be taken as negative. Now, my dear students, how do we solve these sort of basic questions which are asked? In this particular question, you have to check the value of delta S. How do you exactly check the value of delta S? Try to understand. Stoichiometric coefficient here is 1, here it is 3. So on reactant side, we have got 3 plus 1, 4 gaseous moles. On product side, we have got 2 gaseous moles. So when this reaction is happening, what is happening to the number of gaseous moles? Gaseous moles are decreasing. And if gaseous moles are decreasing, what does that mean? What does that mean? That means the degree of randomness, the degree of disorderness will be decreasing. And if disorderness decreases, that means entropy decreases. And if entropy decreases, the value of delta S has to be negative. As simple as that. Stoichiometric coefficient here is 1, here it is 2. So during the process, the gaseous moles again are increasing. Gaseous moles are increasing means disorderness will be increasing. Disorderness increasing means entropy increasing. Entropy increasing means delta S positive. As simple as that. Solid is getting converted into gas. If solid is getting converted into gas, that means automatically disorderness will increase and delta S value will come out to be positive, right? And this particular answer, you guys are going to let me know in the comment section of this particular video, right? You need to tell me the value of the sign of delta S in the last reaction over here. This was one more frequently asked question when it comes to the chapter thermodynamics, particularly the concept of entropy change during the reaction. Now, my dear students, one more thing from the chapter electrochemistry. First of all, you will be asked which of the following has got more oxidizing power, which of the following has got more reducing power. For that, you just have to remember two statements. My dear students, more the SRP of an element, more will be its tendency to undergo reduction. Better will be the oxidizing agent, more will be the oxidizing power. Statement number 1. Statement number 2. More the SOP of the element, more is the tendency of an element to undergo oxidation. Better will be the reducing agent, more will be the reducing power. For example, these are the reactions which are given to me. In the first reaction, A positive is undergoing reduction. B positive is undergoing reduction. C di positive is undergoing reduction because everywhere gate of electrons is happening, right? So what are these values exactly? These are the standard reduction potentials. Perfect. Now, my dear students, which value is maximum among the three? This is the maximum value, right? So more the SRP of an element, more will be the tendency of an element to undergo reduction. Better is going to be the oxidizing agent. More is going to be the oxidizing power. Perfect. So basically, if I need to arrange on the basis of oxidizing power, what will be my answer? My answer will be B positive will have maximum oxidizing power. Since B positive, it has got maximum oxidizing power, followed by your A positive, followed by what? followed by C die positive. This is the order of your oxidizing power, as well as this is the order of your oxidizing agent. Okay, right? If they ask you which of the following is the better oxidizing agent, you will say B positive is the better oxidizing agent, followed by A positive, followed by C die positive, right? Similarly, my dear students, they can give the reactions in the reverse format, wherein SOP will be given. And if SOP is given, you can talk in terms of reducing power as well. I believe this sort of a question is clear to everyone. And my dear students, for the handwritten PDF of this particular session, I would want you guys to join my Telegram channel. The name of the Telegram channel is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of the Telegram channel. On which I keep on sharing all these handwritten PDFs, which is definitely going to save your time as well.